Hello, everybody. Thank you for joining me for this presentation about plastic pollution. Can you hear me well? Yes? Okay, good. My name is Christelle A NOT. I'm senior lecturer in the Earth Science Department of the Science Faculty of HKU. And as part of my work, I do research on plastic pollution. So today, I will give a relatively general presentation about plastic pollution, and I would like to focus on the solution. What are the different solutions? So the title of the presentation, and I will switch this one now. It's from awareness to action, so tackling plastic pollution and building a sustainable future. And I would like to have this presentation relatively, you can stop me anytime if you have any question, but we'll have also a question period at the end, so don't hesitate. And I will start by asking you a question. So in Hong Kong, based on your point of view, how much plastic waste do we discard or do we produce every day? So 1 ton a day, which is equivalent to 1 kilogram per day, 10 tons a day, 100 tons a day, 1,000 tons a day, or 2,000 tons a day. So who thinks, and we'll just raise hands to go quickly, who thinks is A, B, C, D, E? Okay, so it's all on D, E, or D. So 1,000 to 2,000 tons a day. And the answer, it's 2,000 tons a day as a population. So if we separate that in terms of the quantity that each of us are producing or discarding, it's equivalent to approximately 0.3 kilogram of plastic per day per habitant. 300 grams of plastic is equivalent of 12 plastic bottles or 50 plastic bags, meaning that every day, each of us put to the garbage, and we'll discuss which garbage later in the talk, but put to the garbage, potentially to the landfill, 12 plastic bottles or 50 plastic bags. Okay? So I want you to keep that in mind where we'll discuss solution later on. But first, I want to really take a step back, and for everybody to be on the same page, I want to explain what are the plastics. So plastic, they are fossil fuel-based molecules, meaning they are made of fossil fuels, okay? And they are a combination, they are very long chains of fossil fuel-based, what we call monomer or polymer. So combination of a small organic molecule that we call monomers and a long one that is so this is one monomer, another monomer, two different ones, and we just combine those two thousands of times, tens of thousands of times to give a polymer. And a polymer will be, for example, PET that you might have heard. So this is, for example, PET molecule. On top of those, a combination of monomers, we had additive in it. And additive is a word to encompass every chemicals that is added to the polymer structure to change its color, its resistance to UV, its capacity to shape. So there is a lot, there is thousands and thousands of different chemicals that are encompasses when we say additives. But in general, a plastic is a polymer plus additive. Okay, so very long chains of carbohydrates. So since when and why we have plastic? It's all started with pool balls. And pool balls were used to be made by ivory. And in the beginning of the 20th century or late of the 19th century, there were not enough, or we were lacking, it was more difficult to get ivories. So there is a new polymers that's called celluloid that have been developed to make pool balls. And it's how we started the production of plastic. So celluloid was the first polymer that was invented at the late 19th centuries. And then in the early 20th centuries, we started to have other types of plastics, so other polymers that we call PVC, PET, PE, you all know those names, or nylons. And we started to really developed them. And this is early of the 20th centuries. Then the Second World War really triggered the increase in the demands because it was way more difficult to find other type of resources and to exchange them between countries. So there were needs to produce material that we can produce product with it at a very small, very locally. So we don't rely on other country exchange and trades. So there is a first development of increase in the production of plastic polymers during the Second World War, which is relatively recent. It's 70, 80 years ago. So, and this is really when we started to produce plastic in an industrial quantity. It's really, really the beginning of plastic production. This is a cover or a page of a magazine, the Life magazine in 1955, that explained how plastic can change our lifestyle. Because it could be a throwaway living, meaning that, and in the notes in the paper, it said you don't have to do dishes anymore. You can use plastic plate, plastic cutlery, then you don't have to spend time to do dishes. You can just use the plastic and then throw them away and get new one next time you need to eat. This is 1955. And since that, we have increased our demand and our production of plastic. And more than half of the plastic that we ever produced have been produced in the last 20 years. So very, very recently, we produce plastic for 70, 80 years, and at least in the mass production, but half of it is in the last 20 years. If we look at that information in a diagram, and if we look at, so this is, you have the time here, and you have the production in millions of tons of plastic produced worldwide. So you see 1950, Second World War, beginning of the production, and we have an increase up. So 2024, we are over 400 millions of tons of plastic produced. And again, you see the trend, rapid increase, an exponential increase. And what the prediction are saying is, this is the forecast. The forecast is that it will more than double in 2050. So we'll go over thousands of millions of tons of plastic produced if we keep the same trend by 2050. So we are producing more plastic, and then we are seeing image like this. And I'm sure you all have seen those type of image. We have waste. We have a lot of waste. And again, this is not only plastic, but it's part of the problem. So we have this, and then we have those type of pictures. Those are all taken in different coastline of Hong Kong. Might recognize some. So we have more sandy environment, we have a mangrove, and we have more palm. So we have plastic that end up in the environment. And I will explain you how that is a problem, and then we'll try to think together how we reach or how we pass from this high production to this image and to that. Just to give you an idea, this the fact that the plastic end up in the environment, and I will have a focus on the marine environment because traditionally the scientists have looked at in the ocean where are the plastic and how they end up in the ocean, but more and more we recognize that it's not limited to the ocean. And anybody who do hiking in Hong Kong have noticed that we see plastic on all the trails. So the terrestrial environment is also impacted by the plastic, but scientists had a look at it a little bit later, so we know less than in the marine environment. So I will focus for the marine environment. And there is studies that show that approximately 40 million tons of plastic enter the ocean every year. This is equivalent of a garbage truck per minute worldwide. So what are all those plastics that we are all using? And we found them in the ocean. What are there? So when we look at study worldwide. This is a map of the world. And the information you have here, you have two types of information. The first one is a proportion of plastic debris that are collected. So the size of the round gives you the proportion. You see that it goes from less than 80 to plus than 90%. So the bigger the circle or the more we have plastic in the waste that is collected. And the second information is the color that gives you the type of usage of the plastic that we have collected. So if it's green, it means it's food related. It could be a plastic bottle, it could be a fork, it could be a plastic cup, anything related to food, anything related to tobacco, so mostly the cigarette butts. Then everything related to fisheries, so it could be nets, it could be the small buoy that are also used to maintain the buoyancy of the nets, etc. And others, it's a more general category. But what I want to really show with that map, and there is some geographical distinction, but one that is very, most of the time, the most abundant is food-related products. And this is particularly true in our region in Asia. So meaning that most of the debris that we find in the ocean are related to food consumption. And again, when we want to think to solution, it's important to know that. Yes? It represents the area. So all that pie chart represents the data from the pink dots. That one's from the green dots. Just to give you an idea of the quantity of data, it's hundreds of thousands of beach cleanup data that have been combined together. Now, I just want to look at the same information, but we focus on the food-related item, just to give us an idea what they are. And again, idea is, what are the solutions? What can we do? So if you look at a food-related item, and if we take the focus on the Asian region, the one that we lived in, plastic bottles are very important. Straw and stirrer are also very important. Food wrapper and container. If we connect that to what we do in our usage, it's all items that we use almost on a daily basis. Most of the people use on a daily basis. Okay? So just to give you, what do we see and what are those items? And those are data, global data, but if for people who have done a beach cleanup, those are pictures from Hong Kong beach cleanup. It's really items that we found very recurrently. All those boxes, take out boxes, for example, there is straw here, etc., etc. Now I have another question for you. So this is in Hong Kong, focusing on Hong Kong. What do you think is the most important one? The plastic bottle, the plastic bag, the food container, or cup, or etc., or plate, the cutlery, so fork, or the cigarette butts. So who thinks it's the plastic bottle? The answer A, answer B, answer C, answer D, and answer E. When you look at it, it's almost equivalent. It's almost all of them together. It's almost like 20% each. So all of those items are, you're all right, more or less. All of them are really used and found in Hong Kong beach all the time. So the problem is 40% of the plastic items that we throw away have been used for less than a month. And this leads also to, okay, what type of solution we should bring? Because if we say, okay, all what we found on the beach have been purchased and used for a very short period of time. Okay? And again, we'll come back to that when we think about solution. So we know that we have all those plastic that are related to our usage, but while those are really important, they might be in the environment and be very inert, but it's not the case. And most of you, I'm sure, have seen those pictures of marine life that is affected, that is, so For example, a bird that will be died by starvation, it will have the stomach full of plastic, thinking that it's full of food, but it's only plastic, so there is no nutritional value. It cannot survive with that. So this is really one of the important problem or issue related or impact of the presence of plastic in the marine environment. But I want to say it's not even the most important one. It is important, and it is clear that marine life, and especially seabirds or bigger organisms like turtles, we know that there is a lot of sea turtles that are affected by the plastic. The food jellyfish may be confused with a plastic bag, for example. So yes, there is all those encounters that have an impact on marine life. But I want to say it's not the most important one. The most important one, that all of those plastics that we call microplastic based on their size, they are not inert, and they will fragmentate under the sun, under the wave, under the wind action. They will fragmentate, so they will break down in smaller pieces that we call microplastic. So microplastic are plastic pieces that are smaller than 5 millimeters. And we will see later how those microplastics are even a bigger problem than the microplastic. Just to give you an idea, the fragmentation process. So one straw, can you estimate in your head how much microplastic pieces is generated in one single straw? So as I say, microplastic are 5 millimeter or smaller than 5 millimeter pieces. And in the scientific community, we usually have two size boundary, the 5 millimeter and the 1 millimeter. Okay, so all of those. So just to give you an idea, a straw corresponds to 165 by 5 millimeter pieces, and over 4,000 1 by 1 millimeter pieces. So in one straw, potentially, it can generate thousands of microplastic pieces. If you want to get another guess, this is something that I'm sure all of us have consumed in the last couple of years, a coffee or a cup from drinks. Just to give you an idea, in one cup like this, there is 1,500 5 by 5, so the largest microplastics we can even find, 5 by 5, and over 38,000 1 by 1 microplastic pieces. So when you look at the data that I showed earlier on the quantity of macro debris that we have and the type of macro debris, that you see how all of those fragmentate under sun, under UV, under wave, under wind, and they generate those microplastics. So what are the problems with those microplastic pieces? These are microplastic pieces collected from the ocean. So here still in suspension in water, and here they are dry. And as a scientist, what we will try to do is try to count all of those pieces, try to identify. But the first difficulty that we have is, does that pieces come from a plastic bag or from a label from a PET bottle? There is no way, at least no easy way to know that. So the first difficulty with those microplastics is we don't know their source. We know that they come from the big one, but we don't know if it's plastic bottle, if it's a straw, if it's a bag. So when we want to come to a solution, it might be a little bit more challenging if we just focus on the microplastic. But this is probably the first difficulty. It's we cannot identify the source. The second problem related to microplastic is, so usually what we will do, it's we will organize them by shape. And this represents the average microplastic proportion of Hong Kong waters. So in Hong Kong water, almost half of the microplastic that we found on what we call their styrofoam or expanded polystyrene pieces. So, you know, all the small white boxes for the vegetables, for the fish market, but also some of them for takeout food, the white boxes. So they fragmentate in very small pieces, and they represent almost half of what we found as microplastic in Hong Kong waters. Another part, what we look at is the hard fragment. So typically, plastic lunch boxes or a PET bottle will generate hard fragments. The film will be food wrapper, plastic bags, but they represent approximately 7% in Hong Kong waters. Fibers are very long thread like this. So they have different sources. Some of those sources are fishing gear, but it could also be clothing. Synthetic clothing will generate a lot of fibers. And in some part of the world, those are the most abundant type of microplastic that are found. And then the last one, here we call pellets. And pellets, they are slightly different than the others, and we'll come back to that at another point. So the first problem is that we cannot identify the source. The second problem, it is very difficult to clean microplastic. It's easy to pick the cup, the Starbucks cup that I show you. It's way more difficult to pick the hundreds of thousands of microplastic pieces generated by the fragmentation of that big cup. And this is one of the difficulty with microplastic is they are difficult to clean. Where it's easier to pick up a bag, it's very difficult to pick up all the small pieces. The third is they can be more easily ingested by way more marine organisms. The smaller organisms, and we will see after crabs, some oyster, mussels, any plankton organisms will be able to ingest those smaller pieces. Where they won't be affected by the big one, they will be affected by the smaller one. So they are, as I said, an even bigger problem. And this is just a couple of examples. So this is a crabs, and we look at the stomach and the gill, and we found, unfortunately, microplastic pieces inside the crabs. And this is a razor clam, and same thing, we found a different type of microplastic in. And in Hong Kong and everywhere around the world, there is hundreds of studies that show that marine organisms are ingested microplastic. And if you go in the environment, so this show you a small video here, you see that there is a crab, and the crab is playing with small pieces. Okay. You see, there are always fragmentation. So in fact, we say fragmentation happens with the sun, but animals also play a role in fragmenting, in breaking down the big pieces to the smaller one, making them available again for them. Sorry, I don't want to. Okay. Another issue is that they are carrier of other pollutants. And there is studies that have found heavy metals that are attached at the surface of the microplastic pieces. There is organic POP, persistent organic pollutants, that also attach at the surface of those microplastics. So when those microplastics are ingested, they're also carrier of other elements, and then they can fragment themselves in smaller pieces, and that we call them nanoplastic. So meaning these microplastic, once they are in the environment, they have the same, they're under the same stressors than the bigger pieces, and so they generate smaller pieces. If they generate smaller pieces, similar type of problem happen. The smaller the pieces are, the more difficult they are to clean. The smaller they are, the more easily they are ingested. And there is study now that show that each of us as human, we ingest microplastic on a daily basis. So why do we have, those plastic in the environment? As I said from the beginning, it all goes back to that, to this very, very rapid increase in the production And when we had increased the production, we, as a society, we didn't think about waste management. So we have increased our demand, we have increased our need, we have increased our production, but we haven't increased, or we haven't think of a good way to dispose plastic items. And this is the reason we have them in the environment, because we don't have, and even today, we don't have, at least at scale, a good solution to manage all of those plastics. The plastic have been produced because they are very resistant and they are very flexible, so we can do a lot of different things in plastic, but they are also very resistant. And we didn't think about what do we do when we don't use those plastics. And I remember, and if you remember, I said that 40% of the plastic are put into the waste only after a month after being bought, meaning that we really need to find a rapid turnover and a good waste management of those plastics that we are producing if we want to find a solution. So from your point of view, what is the solution? What we should put in place? Shall we increase the recycling? Shall we ban certain type of products, so ban certain type of plastic, for example? Shall we develop legislation to reduce the plastic production? Saying we should have like a little bit for the climate, for the one who are more into climate, we say, okay, we should limit our emission of CO2. Shall we have a similar strategy? Shall we limit our production of plastic worldwide? Shall we develop new material, better material, plastic-like material, what sometimes are called bioplastic? Shall we reduce our use of plastic? So who thinks A is the solution? B is the solution? Who think it's C, D, and E? Yes, it's all. It's probably all, because one way we won't be able to solve everything. We need all of those together if we really want to have an impact in the plastic pollution issues. And all of them are happening, but all of them have limitation. And this is important to keep in mind. Yes, please.
It's all except A.
What do you mean?
I mean, solutions are all except for A.
You don't think recycling is a solution?
We know it's not happening, so it's not.
Well, we can push for more.
No, but the problem is if you recycle, you have more microplastic as well.
It depends. It depends how it's done. And recycling, in fact, it's a big, it encompasses so many things. Because you have recycling for the similar material, and I will give just an example after. You have what we call chemical recycling, where you completely, if you destroy the chemical structure to redo new polymers. So you go back to the monomers. There is so many different recycling techniques that are at the moment done. But I agree that it's probably not the one we should rely on the most. Yes?
Are you aware chemical recycling is actually not really, I mean, it's just the industry promoting that concept, but it's not actually workable.
I have colleagues here in science faculty that are trying to develop new chemical recycling. That being said, it requires energy. There is a lot of resources that are needed in that. So I'm not saying that it's the solution and we should put everything in the recycling. And it's what I want to also, even the most basic recycling, there is a lot of drawback to that. And this is one of the messages that I want to share. It's we should not think, okay, let's use as much plastic as we want because recycling will happen. And I just want to give, and we can discuss more after that. So I will go through all of those solutions now, and we will discuss, how they are, how mature they are, and how much we can probably count on them in the future. So let's start with recycling because it's probably one of the solutions that for most of the people are the way forward. If we know that we are not necessarily doing a lot of recycling, but if we increase our recycling capacity, we should be able to better manage our plastic waste. So at the moment, 8% of plastic are recycled in Hong Kong. Worldwide is 18%. So it's not much better. So one of the major reasons is the lack of recycling facilities. But it's not only that. Just to give you a sense of comparison, 35% of paper is recycled in Hong Kong, and more than 90% of glass is recycled in Hong Kong. So again, in terms of plastic, and there is a couple of reasons for that. And those are the reasons. So first, the capacity. So there is very limited recycling facilities, plastic recycling facilities in Hong Kong. They have different type also of plastic recycling facilities. One of the more simple, if I want to say, a plastic recycling facility that will lead to microplastic generation, and I agree with you, the plastic will be shredded in smaller pieces and then sent somewhere else for reuse, to be remelt if it's a pure polymers, to do other products, or to do other type of products. So it's really a shredding activity that is done here. Not all the polymer can be recycled. Some are, PVC is probably the best example. PVC with the chlorine element that are in it make it very dangerous to recycle. So there is certain way to do it, but it's really not something that we can do easily. Not also a product, for example, who have several plastic layers from different type of polymers. This is also way more difficult to recycle than something that is in a single polymer. So just give an example, PET bottle. So the plastic drinks bottles, I'm happy I don't have example to show you, so it's a good sign. But if you have a plastic bottles, the plastic bottle is made of PET. Usually the cap is made of different polymer, PE most of the time, it depends. And the label can also be made to a different type of plastic. So you cannot put everything and recycle, you need to split them. This is also add, and the plastic bottle is a very simple example. Tetra Paks, there is liner, or most of the paper cup, they have also a liner of plastic in it to hold the drinks, the liquids, that adds the complexity. As I said, not all the polymer can be recycled, and when they are mixed in the product, it really makes the recycling more difficult, more challenging. And this is something, as a solution, we should, designer of products, if we want to help the recycling, when the product is designed, this should be keep in mind. Can we simplify the type of plastic that is used to make only one plastic? Then it can be increase the recyclability of that product. You need quality plastic to do recycling. Yes.
So you didn't mention about the chemicals. Once you recycle, you also combine different chemicals together, and then it becomes more toxic.
Yeah. So
that's another reason why you can't recycle. So.
Yeah, and usually the recycler, they don't mix all the plastic together, because what you do with the combination of polymers, you cannot redo. So, and I will give the example just after from the PET bottle. You just want PET because you want to be able to redo a PET bottle. So you don't want to have the label that is made of PVC in it. You want a unique type of polymer to have efficient, and this is part of the quality. You need quality, so you need a polymer that is not damaged. And for example, a plastic bottle that has spent a couple of days already in the ocean under the UV, and the polymer will be, the plastic won't be as good as the quality. It won't be recycled because the end product won't be as good as a new plastic. So they don't want that for the quality. So the quality of the product that you put in the recycling is also very important to maintain the quality of the plastic, the new plastic that is made from the recycling. Upcycling, so downcycling. So you also need to be able to have a production chain that accommodate those new type of plastic that you are putting in. price. It's something that I haven't mentioned, but today, for most of the plastic, it's cheaper to produce plastic with fossil fuel than with the recyclable equivalent of the polymer. So meaning that there is no monetary incentives to use recycled plastic for the producer at the moment. Again, can change. So just give you an example, Hong Kong has the first, so they opened a year and a half ago, the first large-scale PET bottle recycling here in Hong Kong. It's a combination, it's Swire Trust, Alba, so Coca-Cola, more or less, the one who produced the bottle and the one who do the waste management or the waste collection that partner together to build PET bottle recycling. So as I mentioned, it's not one also for the recycling, and it's based on the quality. So for example, approximately you need 4 used bottles to produce 3 new bottles, meaning you always have an input of new polymer in it. So again, the recycling is not, you get 1 bottle and you will produce a new bottle made of recycling plastic. No, it's not the full material. So there is, but this is one of the mature recycling that we have in Hong Kong. Another one is styrofoam. This is Missing Link. It's polyfoam recycling scheme. It's one of the, again, Hong Kong-based that recycle styrofoam. They are facing difficulties of sourcing, how to make sure that they get enough. They don't, how to collect them. There is enough that is used, but how to collect it, how to make sure you have enough collection that is clean enough, and then what you do with them. And they have a good, they don't get enough of the different type of styrofoam or expanded polystyrenes to produce what they want. They are selling the raw material and then producing case for computers, this type of product. So they don't get enough, meaning that we don't separate enough, or we don't have a good transport chain and system to go from the producer of the plastic waste to the recycler. And this is also one of the limitations. They are a small scale, but they are the only one that do styrofoam recycling in Hong Kong. Again, recycling, and I really want to go back to your message, recycling is a solution, but it's not the solution, okay? And it takes a lot of effort, a lot of partnership between waste production to the one who collect. And there is other smaller scale recycler here in Hong Kong who are now partnering. One of them, Recycle, is partnering with SF Express to transport your waste to their recycling plants, to try to increase the demand. But I think there is a lot that can be done on that side. Another solution is the legislation, and this is something that you should all be familiar with. So the first one is, maybe not this one, but the next one, sorry. The first one that Hong Kong, the first plastic-related legislation that Hong Kong has put in place is a voluntary ban on plastic microbeads, and this was in 2021. So plastic microbeads are all the small bits from facial scrubs or toothpaste, and you remember they are part of approximately those 5% in Hong Kong waters. They come from those products. So Hong Kong has put a voluntary ban on the usage of those beads for the producer. But the most important one is the regulation of disposable plastic tableware and other plastic items that is starting in 10 days. In April 22nd, we will, or mostly the restaurants and gathering operators will have to stop using plastic and certain in terms of plastics. So this is the campaign, and this is the summary of the regulation. it starts with phase 1. And in phase 1, all of those items are banned to be sold or given for free, no matter how you want to call it, to the consumer. So no more plastic, oxo-degradable bags. We'll come back to that. But what is very interesting, no more straw, plastic straw, no more cutlery, no more plastic plate, and no more polystyrene lunch boxes. The white one, so all of those will be banned in 10 days, meaning that you won't be able to have them if you go and take out food, which is great. It's a good way forward. Also some plastic gloves. This type of legislation, as we say, it's really part of the solution. It has been done in a lot of different countries around the world. This is really one way to really push forward or to really limit the usage of those plastic. This is the phase 1. There is a phase 2 already planned that adds some of those items. So for example, here you don't see the cup, the Starbucks cups, don't want to name the company, but any drink cups or the transparent food container, they are in the phase 2. There is no exact date for the phase 2 yet, but they are already planned to be reduced. So meaning that if you go, of course, if you dine in a restaurant, you should not have access to those items in plastic, but also if you take out, they should be replaced by other solution, either a reusable one that you will wash, and for the one who order Food Panda, for example, they have a service that you can have a reusable lunchbox. So you pay, remember if it's $5 or $10 extra in your order, and then you say that you will give them back the box and they will give you back the money. So also restaurants will accept, they now have to accept, if you bring you with your own box to put the food in, they have to accept it. Then you can go back with your box, wash your box, and then reuse it. So this will really have an impact. If you go back to what type of waste and micro debris we found in Hong Kong environment, you know, the straw, cutlery, plastic cutlery, expanded the EPS boxes, we found them all the time. This should have an impact. This is not only, this is Hong Kong local, but I want to point it out to, in a couple of days, we'll have also the UN International Negotiation Committee on Plastic Treaty. Is the 4th one in the last 2 years. The last one was in November, so every 6 months. And really, they are really there. So it's all the different countries that meet, like for the climate change and CO2 regulations, all the countries that meet to discuss how the plastic should be, the usage of plastic should be reduced. There is discussion to reduce the production, to have some target level of production, and this brings the notion of essential plastic. What are the plastic that are essential? If we think about the medical usage of plastic, there is a lot of plastic used for medicines and surgery, and those are plastic that should be considered as essential. The one that, for even if it's single use, but the one, for example, the straw should not be considered. There is a lot of very intense conversation worldwide about, okay, what should be included in bans, but maybe we should also target reduction and at least a quota in plastic production, and what should be those quota. There is a group of scientists worldwide that work very hard to provide scientific knowledge to the people who are negotiating those treaty for the different countries. So really, this is really happening a lot. Another solution, it's new material. So that most of the time we put them under the words bioplastic, but it's more complex than that. And I will be very fast. I don't necessarily want you to go through that, but I want you to look at the picture, because I think some of the picture might ring a bell on what you are using. If you look at the bags that we are finding around here in Hong Kong, this is the invisible bag that are made of not fossil fuel, but they are made of bio-based polymers. So it's a mixture of bio-based polymer plus starch, so cornstarch or cassava starch. Some of them, however, are made of fossil fuel plus some additives that help their degradations. So there is different type, but all of them, for example, this one is the oxo biodegradables that we call P-Life. There is a couple of shops here in Hong Kong that use those plastic bags. They are definitely helping, but again, they are far to be the solution. And especially those three categories are definitely not equivalent. The ones that are made of fossil fuel, they are also, they have an environmental impact that is way more important. And just to give you an idea, this is different type of bags, the same that you saw in the picture before, and we put them in the air, we put them in the water for 6 months. And after 6 months, look, we find almost all of them. Because all of those bags that are claimed to be biodegradable, they are biodegradable in certain conditions. When the temperature reaches a certain level, when it's an environment in composter, for example, in an industrial composter, which is not what we are, environment that we are experiencing in the nature. Meaning that those plastic bags, those bio-based plastic are good if you have the good waste management facilities. If you have the industrial composter, yes, then they can be a good alternative. But it means that you need to get the industrial composter and you need to really have the system to go from the composter to the waste generation, so to us. So how do we sort them? Like the recycling, it will be a different bin. The one that go to the composter, for example. So we always have to think that, yes, new material are good, and we should definitely, for certain type of plastic, that they are essential plastic, new material, biodegradable material might be a solution, but maybe not for like daily or what we call single-use plastics. And then I would like to finish with habits as one of the solutions. Yes.
Just on the previous thing, the polylactic acid, that was, it says 100%
disappear. Yeah.
So that means that is a solution of polyacid.
But look, it's a solution when it goes in the water, but not when it stays in the, for example, on the forest. So again, it's not necessarily a solution, depends where it ends up. But when you produce it, you don't know where it will end up. What is really important is to really, if we go with those solutions, it's to develop the waste management system. So not only the facilities, but also the transport system that goes with them, the management. Yes?
No, that doesn't mean it becomes microplastic then if it says 100% disintegrated.
It could. And this, yeah. And then, or nanoplastic. Then you don't.
So then it's not a solution either.
Yes. Correct. As I said, none of them are perfect solutions. So the last thing I want to discuss is us, our habits, our consumption, and how can that be part of a solution. And when I was listening to a talk on plastic, somebody showed a picture like this. And for the older one in the room, this was people smoking in a plane. That was okay. That was normal. Today, it makes absolutely no sense. We all know how that can be very dangerous for our health. You know, there is nobody who today see that say, what were they thinking? You know, why they were doing that in a closed environment and smoking? Can hopefully this be like what they were thinking when they were using so much plastic? So it's also a change in our mentality, in our behavior, in our habits. But it's very, very difficult to change habits. And it's the reason we need other solutions. And legislation is a way to force our habits, to change a little bit how we behave. And it's very difficult today to not use plastic. And I will be the first one. I have worked and I know the impact of plastic pollution for years and years and years. Still, I go do the grocery, I buy things that are wrapped in plastic, and I know the problem, but it's very difficult to really change your habits, but you have to try. And maybe, one thing that we should all, I would love you to think about is next time, maybe tomorrow, think about your day and have you bought or used something in plastic? For sure, yes. But even maybe we all use our phone, computers, of course, there is a lot of plastic in it. But do we use a single use plastic? We bought a plastic bottle. Did we bought a cup? Can we try to reduce that? It's all also start with us being aware of how much we use and how much our family use. Then we can try to reduce our consumption. But without us reducing our consumption, all the other solution, the ban, the government won't be able to ban all the plastic. It will never happen. The recycling, we say, it will never be the solution. We won't never be able to recycle even like 80 or 70% of the plastic that we produce because the items are not made also to be recycled properly. There is so much limitation in the recycling. We won't be able also to change all for bioplastic, especially because at the moment, most of the biomaterial that we have are not really, they're better, but they are not a good option so far. So it has a lot to go with also us, the way we use and the way we use the plastic. With that, I will thank you and I will take the